Hey guys, this is the video for the 6-3 lesson. We will go through each of the slides, the huddles. You will still work on yourself, but I will still give you the solutions. So let's go ahead and get started. So the bell ringer says find the slopes of the lines that pass through the following points. So you're going to find the slope of the first 2 points and the slope of the second 2 points. And I'll get you started by giving you the slope formula. Remember, the slope formula is m is equal to the change in the y, so y2 minus y1 over x2 minus x1. So go ahead, pause the video, and work through these yourself, and then when you're ready for the solutions, go ahead and unpause it. So here's the solution to the first one, and it is m is equal to 1, so the slope is 1. I'm going to go ahead and walk you through the second one because for this lesson we're going to have to know how to find slope, so I want to make sure you guys are good to go on finding slope. So our slope formula is m equals y2 minus y1 over x2 minus x1. So I need to fill in, substitute in y2 and y1. So let's go ahead and pick our points. I'm going to make my first point x1, y1, and that makes my second point x2 minus x1. Now we discussed, x2 and y1. And we discussed yesterday how it doesn't matter which point is which, but it does matter that you stay consistent. So you have to stay consistent. So you may have done this one different, but I'm using the second point as x2, y2. So for my y2 minus y1, I have negative 11 minus 2 over x2 minus x1, so negative 18 minus 8. Well, negative 11 minus 2 is negative 13, and negative 18 minus 8 is negative 26. Negative divided by negative is a positive, so my slope will be positive. And 13 over 26 reduces to 1/2. And again, you want to leave this as a fraction. Keep it as a fraction because it is very important for later on in this chapter that we know what the slope is in its fraction form. So keep all your slopes in fraction form. So let's get started with 6-3 properties of slope. And we're going to start with an example. The points negative 20z and negative 13, 2z plus 13, are on a line with a slope of 2. What is the value of z? So we're given 2 points, but there's some unknown values in this point, in these points, so we don't necessarily know what our point is. But this does not change anything we know about slope. We know that slope is the change in y, so y2 minus y1 over the change in the x, so x2 minus x1. And we're going to be able to use this formula to find out what z is equal to. So we're going to use this formula to substitute my points into it and find out what z is. So I'm going to make negative 20 x1. Z is going to be y1. Negative 13 is going to be x2. And 2z plus 13 is going to be y2. And it says we have the line with the slope of 2, so I know that 2 is my m. So I can substitute in what I know into my formula. Well, I know m is 2, so I have 2 is equal to y2, which was 2z plus 13, minus y1, which was z, over x2, which was negative 13, minus x1, which is negative 20. Notice I used parentheses since I'm subtracting a negative. Well, now I can start solving this equation, but first I'm going to do a little bit of simplifying. So I have 2 is equal to, and in my numerator I have 2z plus 13 minus z. Well, I can combine my 2z and negative z, giving me a z plus 13. And then negative 13 minus negative 20 is 7. Now to solve this equation, I have to get rid of this 7 in my denominator. I need to get rid of this. Well, since I'm dividing by 7 to get rid of it, I do the inverse operation and multiply both sides by 7. 7's on the right, cancel out. And I'm left with 7 times 2, which is 14, equals z plus 13. And to finish off solving this equation, subtract 13 from both sides. 13's on the right, cancel out. And I'm left with 1 is equal to z. So z is equal to 1. Now let's go. I want you to go ahead and do this yourself. So pause the video, work it out yourself, use your slope formula, m equals y2 minus y1 over x2 minus x1. Substitute in those points and solve for v. So go ahead, pause the video, and whenever you're done, unpause it to get the solution. So the solution to this problem is v is equal to 4. Now an important step in this is in this step right here. Whenever you subtract your y1, which was 3v minus 1, you have to make sure you put it in parentheses because you're subtracting all of y1. And when you do that, you put in parentheses, you have to distribute the negative, which gives us the negative 3v plus 1 right here. Then it's just a combining like terms and solving, giving us v is equal to 4. Now we need to find the slope of the given line, and the slope of the line passes through each point. So let's go ahead and do that. To find the slope of this line, I need to find my rise over my run. My rise over my run. So let's take a look at my first point. So I need to find out how far I have to go vertically to get to my second point. So I have to go down 2, which is negative 2. Now I have to run and see how far it takes me to get to my second point horizontally. So 1, 2, 3, 4, 5, 6, 7. So that is 7. And since m is equal to my rise over the run, my slope is negative 2 over 7. Now I need to find the slope of the line that goes through these 2 points. Well, slope is y2 minus y1 over x2 minus x1. So, negative 6 minus negative 4 over 3 minus negative 17. 6 minus negative 4 is the same thing as negative 6 plus 4. And the 3 minus negative 17 is the same thing as 3 plus 17. So my slope will be negative 2 over 20, or negative 1/10. So let's go ahead and take a look at these questions. And the first question says, what do these slopes have in common? So look at each of these slopes and see what they have in common. If you take a look, you're going to notice that both of these slopes, the negative 2 over 7 and the negative 1/10, they are both negative. So they have in common, the thing they have in common is that they are both negative slopes. So they are both negative slopes. The next question says, how would you describe the line? So look at the line and check out the characteristics of it and see how you would describe it. Well, whenever I look at this line, I notice that it is going downhill. From left to right, it is going downhill. So the line is going downhill. There's a downhill line. We're going to leave this one, and we'll come back and talk about it later. So let's go ahead and do the next set. We're going to find the slope of the line again and the slope of the points. So looking at the slope of the line, I need to find my rise over my run. For these 2 points, I have to go up 3, and I have to run 1, 2, 3, 4, 5, making this slope m is equal to 3 over 5. So my first slope is 3 over 5. Gotta find the slope between these 2 points. Again, m is equal to y2 minus y1 over x2 minus x1. So negative 16 minus 12 over 6 minus 9. Negative 16 minus 12 is negative 28. 6 minus 9 is negative 3. So my slope is, since a negative divided by negative is a positive, so I have 28 over 3. Now, let's check out and see what these slopes have in common. If you look at both slopes, you notice that they are both positive. They are both positive slopes. So we have 2 positive slopes. And looking at the line, how would we describe the line? Well, this line from left to right is going uphill. It's an uphill line. So, ladies and gentlemen, this can give us a couple properties of slope. And that is, if a line has a slope that is positive, then the line will be going uphill. And you saw that in the last example. We have positive slopes, and the line was going uphill from left to right. So a line with a positive slope is going to look something like this. It'll have an uphill slant to it. And another example is something that looks like this. This one doesn't have nearly as steep of an uphill slant, but is still going uphill. In fact, something that looks like this is still going uphill. A line that looks like this, a really, really steep line, is going uphill. So all these lines are going uphill, so they have positive slopes. So whenever we're graphing these, anytime you're looking at a slope, if you see a positive slope, you know that line will be going uphill. The next property is if a line has a negative slope. So if a line has a slope that is negative, then the line will be going downhill, just like the first example. So from left to right, it will be going downhill. So these lines will look something like this. From left to right, they will be going downhill. So something like that is a downhill slope. Something with a less steep, that is also going downhill. Something that is really steep like this one, still going downhill, so it is a negative slope. So when we're graphing these lines, if it has a negative slope, we know the line will be going downhill. So for this slide, we need to find the slope of the line containing the points negative 3, 3, 1, 3, and sketch the line on the graph. So let's first find the slope. Well, again, finding slope by x2 minus x1. I'm sorry, y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1, which in this case will be equal to 3 minus 3 over 1 minus negative 3. Well, 3 minus 3 is 0, and 1 minus negative 3 is 4. Well, 0 divided by anything is 0, so this time we have a slope of 0. So a slope is 0. Now take a look at what our line will look like. Plot the points negative 3, 3, so point here, and over 1 up 3, point here. And you'll notice that our line It is a horizontal line. It is neither going uphill nor downhill. So it is a horizontal line. Now let's do the same thing for this one. Again, we're going to find the slope, y2 minus y1 over x2 minus x1. So we will have 3. I'm sorry. I doubled up on the slide. I need to skip a slide. I apologize. Your next slide will look like this. Now we have the points negative 1, 5, and negative 1, 1. So now this slope will look like 1 minus 5 over negative 1 minus negative 1. So in my numerator, I'll have negative 4. And negative 1 minus 1 is the same thing as negative 1 plus 1, which will be negative 4 over 0. And we know that we're not allowed to divide by 0. We cannot divide by 0. And if you plug negative 4 over 0 in your calculator, it's going to give you an error. It's going to say undefined. So this is undefined, a UND, undefined. And we go ahead and graph these points, the negative 1, 5, and the negative 1, 1, and connect those points. You will see that we have a vertical line. A vertical line. And in a vertical line, it has an undefined slope. So from those two examples, we can get a couple properties. We have a zero slope. A horizontal line has a slope of 0 and has a 0 in the denominator. So horizontal lines have a slope of 0 and have a 0 in the numerator. 0 in the numerator. So something that looks like this has a slope of 0 over 2 or 0 over negative 12. Doesn't matter. 0 over anything has a 0 slope, and it will be a horizontal line. So a line that looks like the horizon. So something like this, or this, or this. Any line that's horizontal has a slope of 0. And an undefined slope, vertical lines have an undefined slope and have a 0 in the denominator. So this time, with undefined slope, we have a 0 in the denominator. So something like 2 over 0, or negative 12 over 0, or 1,000 or 11,000 over 0. Doesn't matter. Divided by 0, we'll have an undefined slope. So any vertical line, so something like these, those are all vertical lines that have an undefined slope. So with that, we can take a look at Mr. Slope Guy. So you guys finally get to learn about Mr. Slope Guy. You guys have been looking at him all year up on the wall. Now you know how to interpret him, interpret his facial expressions. Looking at his eye that is to our right, so this eye, you see that it has a plus sign as his eye and a line that is going uphill. So that shows us that lines that look like this have a positive slope. And his eye to our left, to our right, this eye, notice the line is going downhill, and his eye is negative. So lines that look like this have a negative slope. And take a look at his nose. This is a vertical line, so line going straight up and down, a vertical line, and his nose is made up of a U. So this tells us that vertical lines have an undefined slope. And look at his mouth. His mouth is a horizontal line, and he has dimples, showing us that horizontal lines have a slope of 0. So this is Mr. Slope Guy. Never forget him. I had a student last year said he was going to get Mr. Slope Guy tattooed on him. Think that'd be a little extreme, but pretty awesome at the same time. So from now on, you'll be able to check out Mr. Slope Guy, and he'll be able to help you out to find which ways our slopes are going. So we're going to finish the lesson up by doing 4 graphs. We're going to graph the following lines that pass through the given point and has the given slope. So the first one we have through 4, 7 with a slope of 0. So I know I'm going to go through 4, 7. So I have to go over 4, up 7. I know it's on your graph, but it's okay. It'll be just 1 above where it stops. So right here, we'll have a point. And I need a slope of 0. Well, Mr. Slope Guy says lines with slope of 0 are horizontal lines, so we're going to draw a horizontal line through 0. Now, whenever you're doing these, it's best to use a straight edge, so get out another piece of paper, an ID card, something to help you keep your line straight, because the straighter the line, well, the better it is, and it just generally looks better. So the next one is through -1, 2 with a slope of 2. So the point -1, 2, and m is equal to 2. Well, I can write this as a fraction. I can write it as 2 over 1, letting me know that my rise is 2, and my run is 1. So I'm going to go to my point, and I can rise 2 and run 1. Rise 2, run 1. Or, since I can write 2 over 1 as -2 over -1, I can go down 2 and to the left 1 and get a point. Down 2 and to the left 1. Down 2 and to the left 1 and get a point, and down 2 to the left 1 to get a point. Now, you don't have to draw this many points, but if you want to, you can. If it helps you, go ahead. And we can sketch a line that goes through all of my points. And go ahead and put arrows at the end so we know that it keeps on going. The next one, we have through the point 3, 4 with a slope of -2/3. So through the point 3, 4, so go over 3 up 4. And I know m is equal to -2/3. Well, I can write -2/3 as -2 over 3 or 2 over -3. And since I know that slope is rise over run, I can take my original point and I can go down 2 and to the right 3 and get a point. Or I can go up 2 and to the left 3 and get a point. And notice I have a negative slope, so my line should be going downhill, which it goes downhill, so I'm good. So that's something you can check for right away, looking at your slope. So the first example, I could have looked at this too, saw that it's positive, and I know right away that my line better be going uphill. And I can start the third one, the -2/3. That slope's negative. I know that I am going to be going downhill. My line had better be going downhill. The last example, through -1, -3 with an undefined slope. So plot the point -1, -3 right here. And I need an undefined slope. Mr. Slope Guy tells us through his nose that an undefined slope is a vertical line. So I have to have a vertical line going through that point. So that finishes up today's lesson. I hope it was a help. Whenever you're done, you can go ahead and pick up our homework from the sub and go ahead and get started on it. It will be due in class tomorrow. Thanks and have a great day.